Professor Chris Hewitt will now walk us through the specific findings that demand our attention. Chris, over to you.
Thank you very much, Co. Several spoilers there. I will indeed go into the details now. We have some slides to illustrate the results. So if it's possible to get those up on the screen, please. Thank you. So this update combines consolidated data from 2024 and preliminary 2025 data when it's available, giving a near real-time view of global climate trends. The findings are mostly not positive, as Co has just said, record greenhouse gas levels, warming, melting. But we do also report some positive progress as well, such as science-informed NDCs, nationally determined contributions, and early warning systems. And as Co mentioned, so we can see on the slide here, we do also provide context for IPCC. I won't go into the details, so that's in the IPCC's report, so their most recent assessment report from 2021, but it serves as background information for context if you're interested. So let's go straight in. This slide here showing atmosphere. So I'm going to show several essential climate variables. And this one is greenhouse gas concentrations. So 2024 is the most recent year for which we have global consolidated figures for greenhouse gases. So that's what we're showing here, but also to note that we do have some figures for 2025. So 2024, the key message here, the greenhouse gas concentrations reach record observed levels. And so the figure on the right, you can see atmospheric carbon dioxide concentrations, for example, going back to 1984. So these are annual averages, and you can see the long-term increase, the trend in atmospheric CO2. And real-time data for 2025 from a few stations shows that these trends are continuing into 2025. The figure at the bottom right shows the growth rate, so this shows the change from year to year, and the key point here is that the increase in concentration for CO2 between 2023 and 2024 was a record increase in the recent observational history, so we're continuing to see greenhouse gas emissions rising. I said I wouldn't go into the context, but I think this one particular one from IPCC is very useful. So the observed increases in well-mixed greenhouse gas concentrations are unequivocally caused by human activities, and continued greenhouse gas emissions will lead to increasing global warming. And so that's a message that we'll see on following slides. Next slide, please. Now on to temperature. So we use 6 global data sets to monitor and assess global mean temperature, and they're shown on the figure on the right there. 3 of them go all the way back to 1850, and then we have more data sets come online. So by 1940, we have the 6 data sets, and these are showing annual average global mean near-surface air temperature going back to 1850. So for temperature, we have data from January to August from all 6 data sets, and we don't have data from all of the data sets from September and October yet. So these results, these provisional results in time for COP, are for January to August, and the average for those 8 months was 1.42 plus or minus 0.12, so we do have some error bars around this. Degrees C above the pre-industrial average, so an 1850 to 1900 average. So what that means is that 2025, this year, is on track to be among the 3 warmest years on record, so the 2nd or 3rd warmest year on record. Clearly, we have several more months to go before the year is finished, but it's on track to be among the 3 warmest years on record, and all 3 of the warmest years on record are the most recent 3 years. In fact, the past 11 years, if we look back, you can see a lot of variability from year to year, but the past 11 years have each been in the warmest 11 years on record, which is actually unprecedented, apart from, of course, the first 11 years, which obviously were the warmest at that time. But since then, so we haven't seen such an extended period where we have such a pronounced warming, and you can see it quite clearly on that graphic. Next slide, please. Moving now to the cryosphere. So this is a figure for glaciers. So we've been monitoring glaciers all around the world, and this graph on the right goes back to 1975, showing glacier mass change, so the balance of masses of glaciers. So in 2023-2024, this is the hydrological year we use to observe glaciers. glaciers lost a record 1.3 metre water equivalent of ice. We've tried to express that in different units. So that's equivalent to 450 gigatons, or in terms of sea level rise, that would equate to 1.2 millimetres of sea level rise. Maybe one more statistic if it helps. We've estimated that would equate to about 180 million Olympic-sized swimming pools if we were to put that water into Olympic swimming pools. These are difficult numbers to get your head around. So a large decrease. 2024, last year, was the third consecutive year that all of the 19 glaciated regions that we monitor recorded a net mass loss. So all of the regions are recording a net mass loss. And Venezuela lost its final glacier, which joined Slovenia. So these are the first two countries to lose all of their glaciers in modern times. Next slide, please. Going down now into the oceans, so there's two figures here relating to the oceans. So the figure on the left, ocean heat content. So over 90% of the excess heat trapped by greenhouse gases in the atmosphere goes into the ocean. So the heat from the atmosphere is driving the warming in the ocean. And so the graphic here shows the changes back to 1960 from 3 different data sets. And again, you can see a clear long-term trend, so increasing ocean heat content, and this is from the surface down to 2,000 metres. And the ocean heat content for 2024 was the highest on record in that time series, and preliminary data for this year show that we are continuing to see those increases in ocean heat content. Ocean warming is irreversible on long timescales, centennial and longer. It can drive marine heat waves, loss of sea ice, sea level rise, degrades marine ecosystems, and can intensify tropical and subtropical storms as well. So this is an important metric to monitor. The figure on the right is sea level. So this is global mean sea level going back to 1993 based on satellite measurements. And again, you can see a clear long-term increase there over that time period. Quite a lot of variability. However, the long-term rate, so if we look at the first decade compared to the most recent decade, the long-term rate of global sea level rise has doubled from 2.1 millimetres per year at the beginning to 4.1 millimetres per year in the final decade. And preliminary data for 2025, you can see on the right-hand side of that figure, there's a slight temporary dip compared to 2024, which needs more investigation, and it's likely due to natural variability. So we saw a similar event back in 2011, if you look, and that was related to large changes in inland water storage. So this is an active area to be studied throughout the rest of the year. Next slide, please. Jumping back to the cryosphere, but building on the ocean results there, so now looking at sea ice. So the figure at the top right is the daily Arctic sea ice extent. So this looks through the year now, and at the bottom is the same for Antarctic, so daily Antarctic sea ice extent. So if we look at the top first, you can see all the different years going back to 1978. They're all plotted on here, and then the 30-year average is the solid black line. And then the blue line shows the picture for 2025 to date. And unfortunately, the 2025 maximum Arctic sea ice extent, so the winter sea ice extent, was the lowest in this satellite record. So that's the lowest maximum sea ice extent in the record. And the whole year, as you can see so far, is below a long-term average. For Antarctica, again, the long-term average, you can see the whole year is below average. It's not record minimum, but it's third record minimum and maximum sea ice extent for Antarctica. So sea ice is below average. Next slide, please. We also document extreme events around the world, and so in the actual report there's more details. So it's in the report you see there's lots of details here, so we've just picked out the key words here. So there's been a diverse range of extreme weather and climate-related events so far in 2025, including heat waves, wildfires, droughts, floods and storms. And these are having major humanitarian and economic impacts, damaging crops, displacing populations, deepening poverty, loss of lives. And the extremes have continued beyond this first half of the year, so Hurricane Melissa would be a recent example in our memory, a clear example of how the year's severe weather is still unfolding. And I see now there's a typhoon, a very destructive typhoon in Southeast Asia at the moment. Next slide, please. I think this is my final slide. So that was all bad news, as Co did warn us. But it's not all bad news, so there are some positive signs as well. So on the left here, National Meteorological and Hydrological Services, these are WMO's members, they're playing a growing role in implementing science-based climate action all around the world, providing climate services and early warnings, such as heat health alerts, agricultural forecasts. And so the graphic on the left shows the reported contributions to nationally determined contributions. So this is where countries are noting the role of climate services and early warnings where they're mentioned in NDCs. And so, for example, the most recent NDCs, more than 70% of those are now referencing climate services or early warning systems. So this is good progress. On the right, early warning systems are, of course, absolutely essential to deal with these extreme events, which were on the previous slide as examples. And so it's very pleasing to see that the number of countries that are reporting multi-hazard early warning systems has doubled. So since 2015, there were 56 countries reporting multi-hazard early warning system in their country, and now we're up to 119. However, 119 means that 40% of countries are still lacking such systems. On the plus side, progress is strongest in least developed countries and small island developing states. And at WMO, we're very much supporting them through improving observations and access to WMO's integrated processing and prediction system to help provide forecasts and warnings. But continued investment is needed in data sharing, forecasting and local preparedness so that we can reach universal coverage by 2027, as called for by the UN Secretary General in the Early Warnings for All. So thank you very much. The science is clear, a bit depressing for most of it. Every indicator is showing the urgency of stronger mitigation and adaptation, but there is encouraging progress, particular expansion of renewable energy, stronger role of climate services and more effective early warnings. The record greenhouse gas levels mean it'll be almost impossible to limit global warming to 1.5 degrees C in the coming years without temporarily overshooting, but it is still possible to bring temperatures back down and limit the size and duration of any overshoot as much as possible to limit the impacts on health, livelihoods and nature. And as has been said many, many times, but it's true, every fraction of a degree of warming really does matter. So we're providing this update at this stage to inform discussions at COP30, and then when the year has finished, we will then produce a report in March of next year on World Meteorological Day, where we'll then report as a final report for 2025. But we feel it's very important to provide this update in time for COP30. So thank you. I'll pass back to Brigitte.
Thank you very much, Chris. And now it's time to open the floor to questions. We have several questions, several hands up here. Jérémy Lange, do you want to start?
Yes, thank you, Brigitte. I had a question for Ms. Barrett. I was a bit puzzled and surprised by your earlier statement saying that you see hopeful signals in the growing recognition in science in shaping policies. I understand that this is the COP and you don't want to lose the momentum here, but is that really the case when we think of not only the US, the backlash right now in the US, but I could name Argentina, maybe India as well. Really, do you really see that science is on the rise in those countries? And do you have maybe examples for me?
Thanks for that question. Yeah, well, I won't go into the specifics in one country or another, but from the perspective of WMO, we are seeing a sharp uptake in the science that we produce. And in the UN family, which we are a part of as a specialized agency, I think we've never had the kind of exposure that we currently have. With the UN Secretary General, we're constantly on the stage sharing the science. So from our perspective, we see a strong uptake in the science. And in particular, we see an interest in the kinds of information we provide for early warning, which is not really a controversial topic. It's really kind kind of goes with beyond questioning that providing early warnings, giving days of warning in advance of hazardous events is kind of a no-brainer in terms of information that is universally welcome.
Thank you very much. And we have a second question from Antonio. Antonio, can you hear us?
Yeah, sorry. Can you hear me?
Yes, we can hear you.
Okay. Oh, sorry. I would like to ask, given that the WMO considers it impossible to avoid temporarily exceeding 1.5 degrees in the coming years, whether there are any projections on when the world might begin to move away from that figure, and what the minimum level of global warming could be reached now if we begin strong environmental policies. Thank you.
You want to take it, Chris?
Yeah, I hope I'm not misunderstanding the question. So we are not yet at 1.5 degrees. So the Paris Agreement refers to long-term warming over decades, and so the results we're showing here are individual years. So last year, the warmest year on record was 1.55 degrees. So that year was above the 1.5 level, and now this year we're below that at 1.42 at the moment. So we've not yet exceeded the 1.5, but we are clearly going in that direction. So at some point in the coming years, we don't know exactly when that will be, the world will exceed 1.5 degrees in terms of long-term warming. And then the big challenge is to, that would be what we would call an overshoot, to bring that back down. But we need to do that as quickly as possible. So we don't yet know how long we would be above 1.5 degrees. And that very much depends on decisions that are made now and as soon as possible, but ideally now. And so that's one of the big challenges at COP30 for the countries coming together. And the plan will be to limit that warming by making it as short and as small as possible to bring the temperatures back down. I'm not sure if you're referring to the UNEP emissions gap report that came out a few days ago. So there they do update based on nationally determined contributions where the world is currently heading. And so they are saying 2.3 to 2.5 degrees C. But with current policies, we're heading towards 2.8 degrees C. So that's where the world could be heading, and so the challenge is to avoid that and bring that warming down and to limit any overshoot, so make it a temporary overshoot as temporary as possible. Apologies if I misunderstood part of the question.
Thank you very much. Antonio, if you want any follow-up, please raise your hand again. Otherwise, I'm happy to give the floor to Bianca.
Hi, can you hear me?
Yes, we can hear you.
Thanks a lot. Here, Bianca Routier from Globo TV, Brazil. First of all, just a clarification. Do you usually release a report like that always before every COP? And of course, this moment is very symbolic in Belém. What message does the WMO want to send now from the Amazon, like with this release? And last point, with China now accelerating the transition, the European Union trying to maintain the leadership, what happens to our planet without the leadership role of the United States when it comes to fighting climate change? Thanks a lot.
So I think there were three questions in there. So the first question, so yes, we do release reports ahead of COP. So every year in March, we release a report looking back over the previous year. So we have the data available by March for the previous calendar year. But this information is absolutely essential to inform the negotiations at COP. So we take the opportunity ahead of COP to consolidate the data that we have available at that point, which is what we're showing in this report here. So that's a rather long answer. The quick answer to your question was yes, we do issue these reports ahead of COP. The second question about the Amazon, so in the report we also summarise some key information from our recent State of the Water Resources report. So the WMO also produces a separate report on the state of water resources. And so there's information there for South America showing, particularly the Amazon region, showing river discharge anomalies in 2024 being much below average. And so there have been, as I'm sure you're more aware than I, there have been droughts and water shortages in South America and in the Amazon. The third question, I'm not sure, Ko, would you like to take that one?
I can take it, but I'm not sure it will be an answer that really gets to the thrust of your question. I mean, for WMO, you know, our expertise is in kind of monitoring the pulse of the planet. So we just don't consider ourselves experts or opine very much on the policy. We are focused on providing science to underpin strong climate action. But with regard to the geopolitics or any of that, we tend to stay in our lane.
Thank you very much. We have a question from Musa.
Yeah, thank you very much. Over the past few years, many countries have announced that they are reducing their use of fossil fuels. According to your report, how has fossil fuel use evolved during these years, starting from 2015, for example?
Thank you. So in this report, we report on the greenhouse gas concentrations in the atmosphere. So we don't report on fossil fuel use. And so fossil fuels are one of the emission sources for greenhouse gas concentrations, but that's not what we do in this report. So we report on the concentrations in the atmosphere. And so, yes, if we go back 10 years, as you said, they have been increasing year on year in the atmosphere, but I can't answer your question because we don't monitor the fossil fuel use.
Thank you very much, Chris. There doesn't seem to be any other question. So before we conclude, just to give you a quick update, the press conference that was planned to take place in Belém couldn't take place because the Leaders Summit was a bit delayed. But our Secretary General is available for interviews. If anyone who is on site and would like to get interviews, please write to media@wmo.int, and my colleague Claire Nullis will get in touch with you and try to set it up. Before we conclude, please note that the findings of this update will be presented again during the Earth Information Day at COP. This will be next Monday to introduce the report to the parties. And it will also be presented during a side event in the WMO IPCC Mary Pavilion. And this will be on the Tuesday, 11th of November. It will be also live streamed, available from the WMO.int website. So thank you very much for joining today. Have a good end of day and bonne fin de journée à tous. Merci beaucoup.